So, sorry we got cut off. We have to continue. And again, I'm on page 24. I think I said the wrong page number earlier, so I apologize. I'm on page 24, and we're finishing up number 9. We knew to go ahead and add these two after we had changed it so they had the matching exponents. So we got 4, or subtract, excuse me, not add, subtract, and so we got 4.09 times, and then we should have it be 10 to the 12th power, since our answer will match the others. One last one of these adding or subtracting. In this case, we're subtracting. We double check to make sure that they match. In this case, they don't. I want to go to the higher exponent, which is -7. So I'm going to change this -8 by moving one place. Therefore, we're going to be using 0.84 times 10 to the -7th power. Now that they match as far as exponents, we can go ahead and subtract. 2.16 minus 0.84 gets us an answer using the calculator to help me, 1.32. And then just like before, our answer would have a matching exponent times 10 to the -7. Last but not least, we have the next part, which is multiplying. Remember that when we're multiplying and we have the same basis, we end up adding the exponents. So we get an answer of x to a plus b. And we're going to use that same concept when we divide. We're going to use our division rule of exponents. So if we have x to the 8th power and x to the b power, and we're going to divide them, our answer would be found by having the same base, but subtracting them, a minus b. So this is again how it connects to what we've been working with. There are 3 steps when multiplying and dividing. First, we multiply or divide the numbers, and then we use the product or quotient rule, whichever one we need, depending on if we're multiplying or if we're dividing. And then lastly, we need to double check to make sure our answer is in scientific notation. And to help us with that, we always use the memory key LARS. Again, that means left, add, right, subtract to our exponents. So taking a look here at number 1, I can see that we're multiplying. We don't have to have anything matching when we multiply. We just simply multiply. So I'm going to take 2.8 times 1.9 using my calculator to help me. I get 5.32. And then times 10, and then this is where our rules come into play. We're multiplying, so I know that we're going to add our exponents of 7 and 4, and we get 11. Again, I'm only going to try doing a few of these odds, and I think we'll catch number 12 as well while we're at it. But I'm going to skip these evens because I don't think you need as much practice. So then again, looking at number 3, I can see that we're multiplying. Nothing has to match when we multiply. We just have to multiply. We've got our numbers, 3.4 times 8.5. Using my calculator to help me, I get 28.9 as my answer for multiplication, times 10 to the, and again, since we're multiplying, we're going to use our multiplication rule or our product rule, and we know to add the exponents, so I'm going to add -2 plus 6. -2 plus 6 gets us an answer of 4. At this point in time, our answer looks a little bit like scientific notation, but it's not, because my exponent is in the wrong spot. I have 2 numbers left of the decimal, and I only needed 1. So I need to move it one place. Notice that I'm moving it to the left. Whenever I move it to the left using my LARS, left means to add. So I need to add 1 to my exponent. So instead of 4, I'm adding 1 to make 5. And number 5, multiplying yet again. And so just like before, nothing has to match. I just need to simply do the multiplication. So I use my calculator to help me. I get 20.72 when I multiply the 3.7 times 5.6 times 10 to the, now I need to remember to add my exponents because I'm using my product rule. -2 plus -3 gets us -5. Double checking to make sure my answer is in scientific notation. It looks like it, but it's kind of in disguise there. Again, I have 2 numbers left of the decimal. In scientific notation, I'm only supposed to have 1. So I'm going to move the decimal. Notice that I'm moving my decimal to the left. Again, that means I need to add. So -1 or -5, add 1 makes it 10 to the -4 as my final answer. Number 7, go ahead and changing symbols. We're now using a division symbol. So we're going to divide our numbers just like we normally would. So 3.72 divided by 1.2 is 3.1. And we've got 10 to the 8th divided by 10 to the 5th. Remember that our rules of division told us to subtract the exponents. So 8 minus 5 will give us the answer of 10 to the 3rd. Double checking, this is definitely in scientific notation, so there's our final answer. Number 9, again, dividing. When we divide, things don't have to match. We just go ahead and divide our numbers. 4.5 divided by 1.8 is 2.5. We double check here and take it times 10 to the, and now here's where we use our quotient rule. Subtract 3 minus -7. So 3 minus -7 is, remember, we're doing our keep, change rule, and we end up with a 10 power. Double check to make sure this is in scientific notation. Sure enough, it is. We only have one number to the left, so nothing needs to be changed, and here's my final answer. We could see it then using the division bar instead of the traditional mathematical division sign. Same thing needs to be done though. We'll take and divide our two numbers. 2.7 divided by 2.4. Using my calculator to help me, I get 1.125 times, and then x to the -5 and x to the -6. So remember, we subtract, so that's -5 minus -6. Keep, change, and that's 10 to the 1st. Scientific notation, usually that's when we do show a 1. I know that we were trying to get into the idea that we don't show it, but scientific notation usually does. If you didn't show it, I would not count it wrong, but again, remember, this is just how scientific notation has their etiquette. As mentioned, I'm going to try number 12 as our last one. Same thing, we're just dividing. Nothing needs to be alike. I just start dividing the numbers out. So 2.0 times 3.2 ends up being 6. Or 0.6, excuse me, read my calculator correctly, 0.625 times, and then x to the 6 minus, using our exponent rule, -6 means that I would have to do keep, change, and I would get 13. Double checking here though, I can see that this is not in scientific notation as I don't have a significant digit over here greater than 0. So I need to move that one place here so that I get 6.25. I was moving that decimal to the right. Remember, Lars tells us as our memory key, right, subtract. So I moved it to the right one. So when I put my exponent, I need to subtract 1. Instead of 13, I would have 12. Your assignment then is on the next page, page 25. And is what you need to complete for Monday.